Okay, for example 4, we are not in the standard form at all. We're going to have to complete the square like we did for vertex form of parabolas or for our circles the other day. So the first thing that you need to do is organize it so that your x's are together. You can leave some space. And then your y's are together. And any numbers are on the other side. So I'm going to move that 9 by subtracting it. Now you'll notice with the y's, you have that 4 in front. So you have to remember that's one of those cases where you factor the 4 out. So I have y squared minus 2y. And then I will complete the square, and when I do, I will multiply by 4 to add it to the other side. So let's complete the square with the x's. Half of 6 is 3, 3 squared is 9. So I'm going to add 9 to both sides. When I do the y's, I'm going to work with this 2. Half of 2 is 1, 1 squared is 1. So I add 1 here, but I'm not really adding 1 on this side. I'm actually adding 4 because of the number in front. So take your 1, multiply it by 4, I get 4, add it to the other side. Then this first part is going to factor to x plus 3x plus 3. So I'm going to write it as x plus 3 squared. The second, I'm going to bring down the 4. It's going to factor to y minus 1 squared. And then over here, when I combine those numbers, I'm just going to get 4. So this is kind of reminiscent of that first problem because I have a 4 over here instead of a 1. So I need to divide by 4 everywhere and cancel things out and reduce. So my equation ends up being x plus 3 squared over 4 plus y minus 1 squared over 1 because the 4 is canceled, and then 4 over 4 became 1. So here is my equation. I can find all of the same things that I've been finding. If I look here, here's the center is at negative 3, positive 1. A is the square root of the number that's under the x's, so square root of 4 is 2. B is the square root of the number under the y's, square root of 1 is 1. C squared would be the big one minus the small one. So 4 minus 1, you get 3. C is either the square root of 3, or if you're trying to graph it, about 1.7. And then E would be the 1.7 over the square root of the big number, which would be 4, and you get about 0.85. You would graph this in the same way that we've been graphing. It's just getting there was a little different. Okay, example 5 is another example like 4. It's just a little bit more complicated. This is almost as ugly as it could get. So we're going to start by completing the square. I need to take my x's and put them together, and my y's and put them together, and send my 16 to the other side. Then both of these have numbers in front, so I'm going to factor out a 16 here with my x's and factor out a 25 with my y's. Then I'm going to complete the square. Half of 2 is 1, 1 squared is 1. To add to the other side, I'm going to do 1 times 16. Then with my y's, half of 2 is 1, 1 squared is 1. Multiply the 1 by 25 and add it to the other side. Then I'm going to bring down my 16. This is going to factor to x minus 1 squared. Bring down my 25. This is going to factor to y minus 1 squared. And then this is all going to combine to 25. Then I'll need to reduce everything. Now this first one's very ugly because 16 and 25 don't have anything in common. So what happens is you're going to basically flip it and stick it underneath. This doesn't happen a whole lot, but it's kind of reversing dividing by a fraction. And so I'm going to have 25 over 16 on the bottom. Here the 25s will cancel, and when everything cancels, you want to still put a 1 to make sure you can get your A's and B's and C's. and then the 25 over 25 becomes 1. So I kept this as a fraction because it's easier to deal with, and when you're trying to figure out a, you'll realize that, because a is the square root of this number. Well, I know the square root of 25 and I know the square root of 16, so this is going to be 5/4. B will be the square root of 1. C squared will be 25 over 16 minus 1. And if we go ahead and take the square root of that, you get 0.75. So C is 0.75. And your eccentricity would be 0.75 over the square root of 25 over 16, which is about 0.6. And again, you'll go about graphing that the same way. Just be careful when you're graphing that 5/4, you might want to think of that as about 1.25 so that you locate things in the correct places. Okay, now we're going to work backwards. We're going to have some points and write the equations from those. So I'm going to give you the foci and the vertices, and we're going to write the equation. So I'm going to actually have to sketch this out and figure out what's going on first. If my foci are at 0, 1, right here, and 4, 1, I can figure out where my center is, because my center would have to be right dead in the middle of those. So if this is at 0, 1 and this is at 4, 1, my center has got to be at 2, 1. So that helps us out there. That also tells us that the distance here between the center and the focus point is 2. So my C is 2. The other thing they gave me are vertices at 5, 1 and -1, 1. So those are my major axis vertices. And what that gives me is this distance here, left and right of the center, and that distance is 3. So since it's left and right, they're giving me the major vertices, the focus points are on that axis, they have just given me A. So I know that C is 2 and A is 3 from that information. What I don't have is B, and so I'm going to have to go to that formula, C squared equals big minus small, to figure out what B is. C squared, 2 squared, would be 4. The big number would be whatever A squared is, and so A is 3, A squared would be 9. Our small number is B squared, and we're looking for B. So I just need to solve this. If I subtract, I get -5 equals -B squared. So 5 equals B squared, and B would be the square root of 5. But in my formula, I really need B squared, so I need the 5. Now I can write my center, x minus 2 squared over something, y minus 1 squared over something equals 1. Then my a squared will go under x, so 9, and my b squared, which is 5, will go under y. Okay, for our last example, we have the foci, but we have a major axis instead of vertices. So again, I'm going to start by sketching what's going on. And my foci are at -2, 2, and 4, 2. And again, my center has got to be halfway between those. So what's halfway between those? 1, 2. So center is at 1, 2. And then I can also figure out my C, because that distance here is 3. So C is 3. Now, if this is where my foci are, this has got to be a horizontal ellipse. And if the major axis is length 10, then that means there's 5 on each side of the vertex. So 5 from the vertex. That also tells me that my A is 5 because this is a horizontal. If this were vertical, that would be B is 5. So I then go to that C squared equals big minus small again. C is 3, so C squared is 9. My big one is A squared, so 5 squared is 25. My small is B squared. So if I work this around, my B squared is going to be 16, and my B would be 4. I can, from there, write my center, x minus 1 squared over something. Y minus 2 squared over something equals 1. the a squared will go under the x, and the b squared will go under the y. You can see me for your work.